Welcome to Introduction to Python and Computer Programming, Part 1 with Inhejuku. So, I'm going to be your tutor for this course. I'm going to teach you everything you need to know about Python. Everything you need to know about Python. So, the main purpose of this course is actually to start the introductory part of Python. Then after we complete Python, we move over to data science immediately. So I'll be anchoring this course. This Python course should be a three-part course. It should be a three-part course. So we are taking the part one now. So without further ado, let's dive in. All you need to do for you to actually learn this course is just your laptop, your PC, your MacBook, any machine you're using that can run codes. Then your mind. I need your mind to be fully attached to this course, and probably you also need a cup of coffee, to chill your mind. So without further ado, let's quickly dive into the course. Introduction. Computers as a machine cannot achieve much without a program. Now, as weird and strange as this statement sounds, but is the fact, computers as a machine can't achieve much without a program. Now, let's take for instance a piece of violin or a keyboard that is just placed on the hallway on a hall without any player. Now, that keyboard has the potential, or that violin has the potential of serving the audience, has the potential of producing sweet melodies that would benefit everyone that gets to listen to it. But that purpose is not, met because there is no player to harness the potentials in the violin or the piano, as the case may be. Now, that's how a computer is without a program. Now, but basically, computers can do simple tasks like addition and division. But these tasks are elementary compared to the various complex tasks that computers do these days. You're probably watching this video from your handset, that's from your mobile, your smartphone, or from your computer. Now, these computers do complex works, and those works you can't just limit them to only addition and division. Now, this is why a program is very, very important and essential. Now, let's take an instance. Suppose you want to calculate the time taken to cover a distance when your average speed is known. Now, but the computer does not know what your average speed is. To cover a distance, your distance is known, your average speed is known. Now, your computer does not know these variables. Your computer does not know these variables because from the laws of motion, from your physics class, you know that speed is equal to distance over time, then displacement is equal to velocity is equal to displacement over time. Now, let's say that your distance is known and the average speed is known. Now, you want to calculate the time taken to cover a particular distance. Now, your computer does not necessarily know what an average speed is. Your computer does not know what distance is, and your computer does not know what time is. So you need a program to, one, accept a number and represent that number as the distance. So you accept a number representing a number as a distance. You accept a number representing average speed. Now, from your physics, you know that time is equal to displacement over speed. So all you need to do is just to divide um the latter, to divide the former by the latter. Then the output becomes the result. So the output of the operation becomes the result. Just these four processes make up a program. Just these four processes make up a program. So you've seen that a program has actually defined the basis of the operation your computer does. So a number representing this distance is defined now, and a number representing the average speed is defined. Now, once you make the basic calculation, you can get your time. Now, this is one of the importance, one of the benefits of having a program. Now, what is a programming language? What is a programming language? Now, a programming language is a system of formal communication used by humans to instruct computers to perform specific tasks. Now, a programming language can you can see it as every other language like English, Chinese, Japanese, German, other languages, Dutch. Now, you can see it as that. So, but is a means of formal communication used to instruct computers to perform specific tasks, because the function of computers is to perform tasks. Now, every programming language consists of, note these following words: syntax and semantics, that define how to write instructions that computers can understand. Now, syntax and semantics rather, that define how to write instructions that computers can understand. Now, programming languages serves as a bridge between human logic and machine processing, enabling the creation of softwares, applications, systems, and other computational tools. Now, the imaginations you have in your mind that you want to harness the capabilities of this particular computer, right? You want to harness it. Then you've thought in your mind, I want to develop this, I want to develop that. You see that programming language now serves as a bridge between what you have in your mind and what the computer does. So you put them down in writing in that particular language you are using, then the computer gets to execute that. Now, key aspects of programming language. Now, every programming language has syntax, semantics. It has other things, but I just want to limit. It has other things, but I just want to limit them to these two important aspects. Now, syntax. Now, this is a set of rules, that's syntax now, that define the structure of a valid program. Now, it actually defines the way symbols, keywords, and operators are combined to form instructions. Now, let's take, for instance, since we are considering Python, let's just take, I've not yet introduced Python, but let's just take this particular statement here that says print hello world. Is a valid syntax because it has followed a set of laid down Python rules. So it won't throw an error because it's syntactically correct. Now, if I remove this parenthesis, this first one, automatically and a syntax error will occur. Now, another key aspect of programming is semantics. Now, this refers to the meaning of instructions in the programming language. Now, consider x equal to 1 plus 2. Now, this is syntactically correct in Python, but the semantics also means that x has been assigned the sum of 1 and 2. You get the difference now? Now, semantics tends to refer to the meaning of instructions in the programming language, while syntax is a set of rules and structures that define a valid program. Now, for this first one, if I'm to take the semantics here, it means that I'm printing hello world. That's what it means. Now, here it means that x x x has been assigned the sum of 1 and 2. Now, let's now move to Python. What is Python? What is Python? Python is a high-level interpreted programming language known for its simplicity, readability, and versatility. Created by Guido van Rossum and first released in 1991. Wow. Python has become one of the most programming languages worldwide, favored by beginners and experienced developers alike. Now, Python is very simple, readability. It is readable. Like Python is readable, is simple, is user friendly, is closer to our language, is closer to what we understand, is not abstract like assembly language, machine languages, like low level language, assembly language. So that's why it's a high level language. Now, applications, web development. Python is used in web development using tools, frameworks like Django and Flask. It's used in data science now. We are heading to this data science. We are also heading to artificial intelligence and machine learning. So it's used in data science, to collect data, used in data mining, data exploration, to explore the data and also to clean the data using tools like NumPy, Pandas, Matplotlib, Plotly, Seaborn, and so Kotlin, and so on. Then artificial intelligence and machine learning, we also cover this one, like machine learning, making predictions using scikit-learn, um, running predictions, linear regression predictions, logistic regression, random forest, and all that. Now, using automation, then used in scientific research, also used in medical scientific research, space exploratory research, and all that. So you can see that Python is very, very versatile. It's used by many fields in life. Now, having introduced Python, so without further ado, let's quit theory for now. Let's suspend theory and go ahead to run Python in your machine. So before you can use Python, it has to be installed in your local machine. So how do we do that? So all you need to do is just to open your Google Chrome. If you're using Google Chrome, open your Google Chrome. If you're using Edge, you can open that. So let's go ahead. So all you need to do is just type download Python, enter. Now, the first link, the one that has www.python.org, then download, you click that. Now it will load. Now, this is Python. Now, this is because I'm using Windows. It now says download the latest version of for Windows, which is 3.12.5. Now, this is the latest version of Python that is stable. So now, but if you're using MacBook, you go ahead and download the one for MacBook. So if you are using Windows, all you need to do is to click and download. So I've already downloaded it. I've already downloaded Python. So it's in my this thing already is in my system already, but I've not yet installed it. Okay, this is Python. So I'm gonna install Python immediately because I've already downloaded it. So install now. Now while you are installing Python, so make sure that you tick this add python.exfile.execution to path. Now, if you do not do this, you have to manually add Python to your environment. So I also like taking this one. So but you can decide to leave it. So I'll click on install now. To request for this, I'll click yes. Okay. Now it's installing Python. It's installing Python. So as you can see, it says setup was successful. So Python has been installed. So all I need to do is just to check if truly Python was truly installed. So all I need to do is just to open my CMD. So you go to your search bar, type CMD. So that's command prompt. So I'll open my command prompt to actually check if truly Python has been installed correctly. So I'll just type Python here and shift enter. So as you can see, Python has been installed correctly. So another way you can also check that is to type Python dash dash version. So this should work. Now it says Python 3.1 to 3.12.5, 3.12.5 has been installed. So Python has been installed correctly. So you can either run Python from the command prompt, or you can use a text editor. So but let's just move ahead to install an IDE, so an integrated development environment that we'll use to run this Python. So in this case, we are going to be using VS Code, but you can also use PyCharm, you can use any other IDE you want to use, but I like using VS Code. I'm familiar with that. I use VS Code for my normal programming, for my normal coding. Then for data science and machine learning, I use Jupyter Lab. So let's go ahead and install VS Code. So all I need to do is I'll just go back to my Google and type download VS Code, enter. So the first one, that's code.visualstudio.com. That's the one. So I'll just click it. Now, this is a little bit tricky. So if you understand, especially for Windows users, so for Mac users, you just go ahead and install. Then for Linux users, just go ahead and install. But for Windows users, you know that Windows now has two okay, yeah, Mac also has that Intel chip, Apple Silicon, and that. So you know that Windows now has two. So the first is normal x86, and ARM, the one that is based on ARM architecture, and the one that is based on x64, rather, yeah, x64. So now, if you click this, the first time I was doing this, I installed it through here, but it couldn't run on my system because my system is based on x86 and not based on ARM. So all you need to do is just go here, click on this x64, click on it and install it. So I've already installed it, so I'm going to go ahead and I've already downloaded it, so I'll just go ahead and install it. So look at it here. Where is it? So look at my VS Code. So I'll click install. So as you can see, Python is working perfectly. Now I'm about to install VS Code, so that we'll just go ahead and start our journey. Yes, next. Okay, now I want that. Next. So I want a desktop this thing. So next, install. So it's preparing to install that now. So it's preparing to install that. So I'm going to come back. I'm going to come back to check it. Okay, we are back. As you can see, it says that installation It's completing the Visual Studio Code setup wizard. Everything is now successful. So I will just finish. So as I click finish, it's going to launch the Visual, Studio Code. So I'll click that. So as you can see, this is the shortcut here. It has already provided the shortcut for me. So the Visual Studio Code is going to run now. Now, if you are up to this point, I want to congratulate you because you are into Python already. So let's start. So all I need to do is just to test if Python is actually here. So just to click on file. Now, once I click on file, now I'm heading towards, I will now click on new file because I just want to make a Python file. So let me just name it practice. You can name yours anything you wish to name it, it doesn't matter. So I'm just going to name mine practice, so that because I'm just using it to practice. So practice. So I'm saving it. So you can create a folder in your document. So it's good to arrange your folders well, to align them well, so that you know where each one is located, so that anytime you quickly need to access a piece of code or something like that, you can easily navigate to that side and check. So I'm going to create this now. After creating that is successful, so let's run our first code to check truly if Python is working. Now print, so I'll just say hello, the famous hello world. So now I'll save, Control S, I've saved it. So now notice I'm in my directory already. So I'm in this directory. So let me run the code now in my terminal. So to run Python codes, all you need to do is just to type Python, then the name of the file, practice.py, then enter. Viola, Python is working. Now let me just show you something. So let me just exit from my directory. So I'm exiting from the directory. So let me show you something, because most of you may encounter this error, especially if you're a beginner. So now I'm out of the directory now. So let me just run the file again. Python, practice.py. Now see what it shows. Can't open file. So it's basically searching for this file practice now after documents. So immediately after document, it's searching for the file, but it can't find it. So you see that. So that's why it's imperative that you are in your directory before you perform any running of the code or anything like that. So you have to be, especially you have to be in your directory. You understand? So now that's that. So now let me go back to by the cd. I'm in documents already. So dev, then what again? By, so practice, sorry about that, Python and practice.py. Now you see that the code is perfectly wrong. Now let's define some terms. Print. Now in Python, in programming language, that is what we call a function. A function. Now, what is a function? A function is actually a piece of code that is out of your, okay, a piece of code that has an effect and returns a value. Now, a piece of code that has an effect and returns a value. Now, you find out that print here in Python, print here is a function. Print is a function keyword. Now, what does this print do? This print takes an argument. Now, what kind of argument does this print take? This print can take any kind of argument in Python. So it can take string, it can take It can take any kind of argument. So now, in this case, hello world is an argument. Now, this is an argument. Now, this hello world, which is an argument, is actually a string. Is actually a string. Is actually a string. So, and this function, which is print, is a function that has an effect and a result. Now, let's go ahead and print something. So, hello world, hello world. So let's say print I just started coding. Then now watch, I'll save Control S. Now let me run this code again. Now you will see that print hello world, the first one, which is this, right? Now the second one is I just started coding. Now there is a line, there is a new line. It didn't just print this particular, it didn't just print this particular stuff, which is the second one, in the same line as this as the first. No, it printed it in the second line. So because this print function, once it executes the distance, so it actually moves over to the new line. It actually moves over to the new line. So, and this print function also can accept no value. So let me just illustrate that. I can say print, just watch what will happen here. Just watch here and see while I run the code. Now just watch. Now you see that there is a space. There is a space. Why? Because the print function, when it is empty, it assigns a new line, a new space. You understand? So that's basically what print function does. And print function is actually a function, so it can take any value that is valid in Python, so any particular value. So you see that this thing now is actually a valid statement. Remember when we talked about syntax and semantics, you realize that this is syntactically correct. So if I, let me just do something here. Let's say here, so let me just remove all these. Now I decide to just remove one, parenthesis. So I'll come back here. Let me just clear. Then I will now say, you see, it's showing a syntax error. Syntax error. Now, the first parenthesis was never closed. You see that? So you see that this is a syntax error. Now, semantics error is actually your interpreter doesn't actually dictate semantics error. You are the one that makes that particular error, but we are going to talk more about that when we discuss when we discuss error handling using exception. So now, how does Python process instructions? Now first one is, let's go back to the hello world. So hello world. Okay, now I say again, Python hello world, hello world. Now let me type another thing. I will say print hello world, I love, okay, let's say YouTube is a nice school. Then print again, print I love YouTube. I love YouTube. So by the way, if you have not subscribed to this channel, please, a subscription will be very essential to us. Thank you. Please subscribe. It will be very essential to us. So let me just run this code. Okay, I've not saved that, so let me save. That's Control S. Then let me run this code. What's that? Okay, now You see, the first one is executed, which is hello world. Now, the second one, YouTube is a nice school. Then the third one, I love YouTube. You see, as you can see that now Python execute instruction line by line. This is the um this is the property of an interpreted language, because Python is an interpreted language. Python is not a compiled language. Now we are going to see this more when we start handling errors, when I teach you how to handle errors using try and accept. You understand? So that is where I'm going to introduce some kind of errors. I will introduce syntax error. I will introduce semantic error, so that you will see the difference. You will see errors that can never be handled unless your can never be encountered unless your program reaches that particular line. So if my program doesn't reach here, automatically this I love you to won't be printed. Now it is line by line, it's done line by line. So if I had an error here, okay, let me just leave that one. When we talk about exception handling, I'm gonna dive more and elaborate more on that. So that is that. So what does a function actually do? So let me just show you a function. So a function is this. So I can say function name. Now a function has an argument. Now an argument is actually a value that is given to a function. So a function has function name argument. So we'll also elaborate more on this when we talk about functions. Now function first. Now how does a function work? Let me just chip in that. Now a function, when a function is written, what does a function do? When there is a function call, now a function, the interpreter, what it does is it first of all checks if the name, let's say this, if the name of this function actually exists. Now for this case, print is a function. So if the name of this print, if this function actually exists, it will check. Now if the function actually exists, the second thing it will actually do is to check the argument that is being invoked. If the argument is within the boundaries of Python, so if the argument is within the boundaries of the maximum allowed argument or the minimum allowed arguments that the Python is function is supposed to accept, and is also going to check if it is appropriate. Now once all these requirements are met, it will now leave your code automatically and jump into the function code. Now once it jumps into the function code, it executes it, then it finally returns a value. Now functions can, in Python, functions can come from your code. Okay, so sorry, from Python built-in functions itself, like this print. It can come from models. It can also come from your code. So when we discuss functions, we'll delve more into that. So so now, can print function accept more than one argument? Yes. Yes. Now watch this. Let's say we want to print okay, I love then I'll now put comma, then I'll now say Python. These are two arguments. So an argument is separated by a comma. These so these are two arguments. So that have been passed into the print function. So let's try and see if it is going to run. So I'm going to clear this. So I will now say Python practice dot by run. So it says I love Python. So as you can see that more than one argument can be accepted. More than one argument can be accepted by the print function. More than one argument can be accepted by the print function. Okay, now let me show you another thing in Python this thing. So that is what we call escape character. Now um let's say I have this code. Now I love, let's say I love Python. I love Python, right? Then I now come down and say print also how about you, then sorry, how about you, then can you guess the the outcome of this code? I believe that you can guess that because it's supposed to print both of them on different lines, on new lines. Print I love Python, how about you? So but this, we can actually achieve this using a new, what we call a new line character. So let me show you how that works. So you see this, I've printed this. So let's say, sorry, I didn't save that. Saved. So let me run the code. I love Python, right? That's what is being showed now. I love Python. So but I want both of them to be in a new line. So all I need to do is to add my escape character, which is a backslash, then n, which starts for new line. Then I will now say how about you? So for me, I love Python. How about you? So I will save and run the code. Sorry, save and run. So I made a mistake in my how. How should I be making this kind of mistake? So how? Then I'll save again. I'll save again and run the code. So it says I love Python. How about you? I love Python. How about you? So as you can see that a new line has been added. So from here it has been broken into two separate lines. So what's actually happening is because we are using a backslash. Now this backslash is called, what it is called is what is it called, sir? An escape character. So we are using it to escape this n. So now this n, now what this n means is new line. It stands for new line. So that's basically why we are using that. So there are other things that you can do. You can also add t here to represent tab, right? Yeah, you can add t to represent tab. So it will just add a tab. You know what a tab means now? A tab should be 4 spaces, right? Yeah, 4 spaces. So you just added a tab here. So this this an escape character, the backslash. So anytime you want to escape something, anytime you want the meaning of that thing to be added, let's say n, which stands for new line, t, which stands for tab, and there are other ones that start for alert, and some other ones that we won't be delving into now because we don't actually need them for this course. So for this, now you see that this tab and the other one is n. So but let me just show you something also. Now let's say, can you guess the output of this code? I just want to print one backslash. Can you guess the output of this code? Can you guess? Let's see. Let me save and print. Let's see. No, let's see. Wow, it's showing an error, syntax error, unterminated string literal. So now remember that this is an escape character. So if you want to print one, let's say you want to specify a part, something like this, a part in your system. So you want to print one of the backslashes. So all you need to do is to add double since it's an escape. Remember, it's an escape character. So all you need to do is just to add two. So you print one. You understand? Now, you understand? So now let's talk about keyword arguments. Keyword arguments that can also come into the print this thing. So let's talk about keyword arguments. So in keyword arguments, we are just going to talk about two. We are going to talk about separation and end line. So let's go back to our previous code. Let's go back to our previous code. So I wrote something here. What did I write? I wrote print what was that? Okay, I love Python, right? Then what did I do? Then I now printed print and I said, how about you? Right? So okay, I love Python. How about you? So let's save our print. I believe you know the answer to this. Now both of them are in different lines. So now let me introduce the keyword argument. So let me introduce end. Now what this end basically does is it actually pushes this one. It actually removes the new line that is automatically added by print. So it now pushes this one to now come up. So I'm going to just watch and see. Let me save. Just keep your eyes on this. Watch and see what will happen. As you can see, it actually pushed everything here. So if I add a space here, so let's say I added a space there. Now watch and see. You see, it has moved everything to be in the same line. It moved everything to be in the same line. So it says, I love Python. How about you? So from our editor, everything is not on the same line, but because we have added this particular keyword argument here, because keyword arguments can also be added in the print function. So because we have added this keyword argument, you see now, and it has removed the new line that is automatically added by print. Now let's do another thing. So we have done this one, so let's introduce another one. Now what is that one called? Let me just comment this. So let me introduce another one. So that one is called sep. So I'll say so let's say print. So let me just use multiple argument now. Then I'll write love. Then I'll write another one. I love Python. Now let me run this code and see. Clear first, then run the code. So sorry, I didn't save that. So sorry about that. Now clear. You see, I love Python. Now watch what will happen when I introduce this keyword argument. So let's say I want to put star. I want to put a comma. So let's save and see what will happen. Now watch and see. It has introduced commas here. So you see what the separation argument does. So it basically goes to where there is separation and introduce what you want to put. So let's say I want to put a hash here. So I'll just come and run it. You see it has introduced the hash. So it will just basically go to the different, where the different argument starts and introduce the argument you've passed to it. So let's try and do a problem. So let me just show you a problem to do. So look at this. Where is that? Okay, now let's try and see if we can replicate something like this. Can we? I star 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 love star 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 Python. This is what we are looking at. I love I star 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 love star 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 Python dot 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 programming. So can we replicate this? Let's try and see. Where is that? So let's try and see. So I'm gonna comment this out. Then let's try and replicate that. It says okay, print. Then it says what? I first, right? Okay. If you are getting it right, then love, then what did he say? Python, right? Now can we go down? Let's say print I love Python, then programming. So let's save and run. Let's save and run and see. Now you see I love Python program. So what are we going to do? What should we do now? If you said SEP, yeah, correct. So we are using SEP here. So I'm gonna introduce. So how many stars was that? We had three here and dot 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 here. So all I need to do is just come back and so I'll put my 3 stars, right? 1 2 3, then comma, so I can add the end line. So this headline, what is it doing? This end now is actually pushing this one forward. So but if I put an argument here now, automatically that argument will precede this particular one, then but everything will now be in the same line. So I'll put my 3 dots to replicate what was asked. So I'll now say Python this. So Viola, we got it. We got it right. So as you can see, we have gotten that right. As you can see, so I will advise you to also do some Python, some operations. There are various operations that you can actually do. There are various operations that you can actually do with the print statement. So with the print function. So we are going to, move over immediately to literals now. Python literals. Now, literals are data whose values are determined by the literal itself. Now, these are data. I know the definition sounds somehow, but these are data whose values are determined by the literal itself. Now, let's take 12 for instance, or let's take 1, 2, or any integer for instance. Now, 12 always means 12. 12 cannot mean 13. 12 cannot mean another thing. 12 always means 12 wherever you take it to. As far as integer system, our number system is valid, 12 always means 12. Now, also let us consider another letter. Let's consider a letter C. Now, the number 12, we know that it always means 12, but the number C can either mean another thing. It can mean the speed of light. If you are from physics class, it can mean the capacitor of a capacitor or other things. Now, having this in mind and having this definition, you find out that 12 is a literal, but C is not, is a variable. Now, integers. Integers are numbers. Integers, these are examples of literals now. Integers are literals now. Integers are numbers without any decimal point attached to them. Example of an integer: 1, 2, 3, 4, 5, down to n, where n is an integer. You understand? So If you did number system in your high school or any school at all, you should know this by now. So we won't dwell much on integer. So because we already know integer, we know what integers are. I believe that we are experts in mathematics. Now, um, apart from integers, there are also two number types that are supported also by Python, additional number types that are familiar with mathematics and they are also supported by Python. The first one is octal numbers and the second one is hexadecimal. Now, you know that octal, you know that computers deal with zeros and ones. Computers understand zeros and ones, so which is a binary system. A circuit can either be off or it can either be on. So that's what it means. Zero meaning off and one meaning on. So now, but apart from that, Python also understand octal numbers. Numbers ranging from 0 to 7. In our own number system, our natural number system, we often make use of decimal numbers. So we make use of base 10. Our system is based on base 10. So everything that we calculate, we base it on base 10, which is decimal. So but there are other number types such as octal numbers and hexadecimal, binary. So now, for you to represent octal number in Python, for you to represent it in Python, the first thing that precedes it is zero. Zero precedes it. So as you can see it here, zero precedes that, then followed by O, then followed by N, where N can be any integer. So for example, this number, this here. So let's rush quickly to Visual Studio Code, VS Code, and try to convert this particular number to the decimal, to the base 10 counterpart. So let's move on to our Visual Studio Code. So we are here. So remember that the number, actually what precedes the number is 0. The first one is 0, then second one is O, then the number 2, 3, 4. Any number can go. So let me say CLS, I'm clearing the space, then Python print. So as you can see, 156 is the binary equivalent of this particular octal number. So this particular number is in base 10, so is in base 8 rather. So I'm just representing this number now in base 10. Now watch, when I remove this thing, what the computer understand, what the Python code understands, let me just type it this way. What the Python code understands is that this particular stuff now is in base 10, is in base 10. But if I now introduce 0 and O, automatically it will be seeing it as an octal number. Then it will now convert it to the decimal, to the binary, to the base 10 system counterpart equivalent. So as you can see that, so this is how you convert. In high school, in the university, if you did computer science, there are methods that you can use there are bit methods that you use to convert this. So but this Python code is just, the Python interpreter is just doing the work for us automatically. So let's quickly move over to the next one. So the next one is hexadecimal numbers. Now hexadecimal numbers are numbers ranging from 0 to 15, where 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, 14 is represented by E, right? So making it 15 number. So it's ranging from 0 to 15. Now, if you want to represent any number in Python, then you want to represent it as a hexadecimal number, all you need to do is to precede that particular integer by 0 and x. So let me show you what it means. So let's take for instance this stuff here, this hexadecimal number here, 0x112. So we are going to convert it to binary. So let me just comment this out. Let me just comment, sorry. Let me just comment this out. So we are going to convert it now to the base 10 equivalent. So all I need to do is just print 0x, right? Now 0x, then I now say 112. So save and print. So I'm printing that. Now as you can see, this is the equivalent value in base 10 of this particular number. So if you actually did electrical and electronic engineering, or you did computer science, you'll be familiar with these particular numbers, especially this hexadecimal, because it is normally used to store, it is normally used as address locations in memories. So you will see a memory that is dedicated, that is represented with something like this. So once you see any number that 0 and x precede the integer, just know that that number is hexadecimal. So it's often found in memory addresses, in memory locations. So when you're talking about memory locations, so that's basically where it's being used. So apart from that, let's also try to convert a number in the binary system and convert it to this thing, to the base 10 decimal equivalent. So let's try. Let's say print, which number should we try now? Let's say now, whenever you want to convert binary, all you need to do is precede that integer with 0 first, then b for binary, then that number. So I'm converting, it's 0. The range is between 0 and 1. So I can say 101010. So let's run the code and see what this number actually represents in the one that we are conversant with, which is a decimal system. So this number now actually represents 85. This number represents 85, right? So this number represents 85. So as you can see, these are the various ways that you can do this. Now this is to this first one is to represent the number in the octal system, that's base 8. Now this is to represent the number in the hexadecimal system, which is base 16. Then this is to represent the number in the binary system. So I know that you've understood this. So I'll also encourage you to try these out. Make sure you try all these out to become conversant with it, and also to benefit and to learn more from that. So apart from that, we have another one which is called float. So we are talking about floats. Now these are numbers with decimal point. Simple. That's just the definition, numbers with decimal point. So let's just quickly go to Visual Studio Code and just try it out. So you can see that, let's say I want to print a number, then I say 2.0. 2.0 is a float. So let me save and see. Then run. You see it's a float. So if I run the type now, if I want to confirm that it is float, so look at how I'm going to do that. So I will just say print, then type. This is a function, type, name type, then I will say 2.0. So automatically, let's run and see. It's telling me the class, it is float. So you realize that any number that has a decimal point, automatically that number is float, and we make use of float a lot in our calculations, in our day-to-day calculations. These are continuous variable. They are gotten from continuous measurements. Yeah, they are not actually discrete. These floats, they are gotten from um continuous measurements like temperature, pressure, and all that. So let's move ahead. Then another one we should talk about is complex numbers. Now, complex numbers are numbers that have two parts. So, as you can recall from your mathematics, from a simple mathematics class, complex numbers are numbers that have two parts. Now, a real part and an imaginary part. Now, they can be written in the form a plus bi. Now, Python also accepts complex numbers. Python also accepts that. So it's among the numbers that Python accepts. So now in Python they are written as a plus b j, where a and b are numbers. You understand? So let's just go ahead and try that out. So I'll just comment this. Then I will now say print. Let's say what's the complex number now? 3 plus 7j. Let's save and run that. You can see it is printing it. So I want to know the type. Let's confirm the type of this number. Can you guess that? Can you guess how we're going to do that? Yeah, if you guessed type, you got it right. So let's put type here. So type, then type of 3. That was what we did. 7j. Sorry, save and run. Now you can see the class is complex. So Python accepts integers, it accepts hexadecimal numbers, it accepts octal numbers, then it also accepts complex numbers. So let's quickly move ahead and see what we have next. So the next literal now is string. Now strings are used to process text. Now, strings are used to process text. As you can see before, we've already depicted this. We've already demonstrated this when we actually talked about this thing, printing function, the print function, because one of the types that the print function accepts is actually string. So let's say I want to print. Let me just comment this out. Sorry about that. So let's just say I want to actually print um hello world, hello world, hello world. Then I save that. I clear the terminal. Then I run it. Hello world. Now this hello world is a string. Now, how do we actually represent string? We represent string with quotation mark. So anything that is inside the quotation mark is actually a string. So a typical string can be this. Strings can also be used to represent your name, addresses, novel, anything that has to do with letters, anything that has to do with that can be represented using a string. You understand? Now remember, in our we talked about escape escape keywords. So where we talked about I hope you can still remember that, where I talked about this where you use escape this thing, where I said suppose I want this thing to be, I want the word to be in the other line, so I can just use the escape character and put n here, which stands for new line. Then I save and I run. As you can see that this backslash is an escape character, so we are going to do a simple a simple problem. So I want us to actually reproduce this. I am coding Python. So I want us to actually reproduce this. So can you do this on your own? Can I give you a few minutes and try? So you can go ahead and pause the video now and try to represent this using Python. So I'm going to try it now. So if you have tried it and got it, kudos to you. thumbs up. But if you didn't get it, just stick around and listen. So we are going to do that now. We are going to do that now. So let me just comment this out. Then, okay, so what are we actually working on? So we want to print. The first one is inside the quotation mark. I want to get I am first, one quotation mark, second, two quotation marks, and three quotation marks. So I want to write I am coding Python. So I want them to be I want the statement to be on the same line. I want the code to be on the same line, but it should output something like this on new lines. So how are we going to do that? So let's just go ahead and try that out. So first of all, write print. Now is a string. I'll put my first quotation mark. So now the first one is inside a quote, which is I am. So can you guess what um we have to do? The character we have to use. Wow, if you said escape character, you got it right. So I'll put my escape character here, then I'll put my first quotation. Now I want to put an apostrophe, so I should put an escape character again, then I put a single quotation, then I am, right? Now I want to, because the statement is actually in a quotation mark, is in quote, so I'll put another this and do that. So as you can see, let's just run this and see. Sorry about that. Let's just run this and see the output. Run this and see the output. So as you can see, I'm almost getting that. Right? So, but I want the next statement. Let's just go ahead and check again. We have gotten this. Now remaining this, but I want it to be on a new line. So how do we do that? Yes, if you said escape character, you are correct. Now new line keyword, then you are very, very correct. Then it's learning, right? So but it's under three quotation marks. So first one is this for first quotation, second, then third, then learning, then we also have to close it, 1, 2, then 3. So let's go ahead and save and run and see. Wow, as you can see, we are almost getting that. So let's check again. Oh, is it learning? Coding. So my bad. So let me just go back and correct that. Let me just go back and correct that. This is coding. Then, as you can see, we are writing everything on the same line. All the statements are on the same line. Wow. This these Python keywords are very, very powerful. This escape keyword, this backslash is very, very powerful. This escape character. So I'm also going to escape again, which is new line. Then how many quotations? Let's see. Okay, this is 3, right? Okay, that means that we made a mistake here. This is supposed to be 2. Okay, this is supposed to be 2, 1. Yeah, let's save and we run and see. Okay, yeah, it's supposed to be 2. Then new line, then let's which is Python. So backslash first, this, backslash again, this, backslash again, this, then Python, then backslash again this, backslash again this, backslash again this. Wow. So let's save and see. Viola, we've gotten that. I am coding Python. So if you got this on your own, thumbs up to you. But if you didn't get it, just practice it. I will advise you to practice things like this. Give yourselves assignments and also practice more of these kind of things so that you become very, very conversant with these Python operations. Now let's quickly move over to, we are going to talk about more on string and some other things that attach to string when we get to operators. So let's quickly move over to Boolean values. Now, Boolean values are used to represent abstract values, truthfulness. Now, the name Boolean comes from George Boole, 1815, 1864, the author of the fundamental work, The Laws of Thought. Now, I know if you are familiar with algebra, you should know Boolean values. You should know a lot about the truth table, then the or, the and, the exclusive or, the not, the exclusive nor, the nor. If you are if you're an engineering student or you're a computer science student or you did computer science, you should know a lot about that, especially gates and all that. So this is how computer basically works. So what computer understands is zeros and one, where zero denotes false or off, and one denotes true or this and on. So let's try and see something. Let's try and let me comment this out. So let's say I want to print, let's say I want to print true. Hmm? This is true. So let me save and print and see output. True is true. So if I print false, I'll print false. These are Boolean values. So if I run the type now, it will show me that it is of the bool class. It is of the Boolean class. You understand? It's of the Boolean class. So I know that you've understood that. So let's try some quiz. Some quizzes. So the first one is, what kind of literature are world and this? Can you answer that? What kind of literature are world then 55? Remember that both of them are in quotation mark. If you say string, you are very, very correct. You are very, very correct. Now, what literals are 1, then 2, 3, 232, then 2.34? What are then true, false? Now, if you say the first one is integer, the second one integer, the third one float, then the fourth one, the fourth and fifth Boolean values are very, very correct. Then the next one is, I will leave you to figure out this one. You can write it on your Python, you can write it on your Visual Studio Code using the one I taught, how to represent, how to convert from binary to decimal. So it says, what is the decimal value of this? So I would leave you to actually do that yourself. So but let's just go ahead and try some things on these Boolean values that we've done. So let's just say this. Let's just say print 1 greater than 2. So let's just do this and see. 1 greater than 2. So it's saying false. Why did it say false? It says false because 1 is not greater than 2. You see that now? Because 1 is not greater than 1 is not greater than 2. So that's why it says false. So if I say, let's say something like let's say 9 less than 30, save and run. You see, it has returned true. So these are how these things are actually done. So let's go ahead and move over to the next thing. So data operation and manipulation. Data operation and manipulation. Now, Python can be used as a calculator. Python can be used as a calculator. Let's show that. Python can be used as a calculator. So I can come here and say print 3 plus 3. Can this work? Let's try and see. 6. So as you can see, Python can be used as a calculator. Now it can also do something like 3 times 3. Then I save that and run it. 9. You understand? So Python can actually do all these things. Then in Python there are basic operators. The first one, addition. Now you know addition now, used to add two numbers. Then subtraction, used to subtract. This actually works the way it works in mathematics. Then multiplication, used to multiply two numbers. Then through division or integer division. Now this is, sorry, through division. Now this is the true division. Let's say I want to divide something. We've done the addition, multiplication. So let's say I want to divide 3 by 2. I want to divide 3 by 2. This is the true division. Now it's giving me 1.5, which is the true division. So this division is actually different from this floor division. Now this one is called integer. This one is called integer division. What does this one do? The first one, which is through division, returns the value. It returns a float. Now, but this one returns an integer. That's why it's called integer division or a float division. So how do you use it? You use two division signs. So let's try and see. So what does it return? It actually returns the integer part of the value of the division. So remember that this one is when we divided 3 by 2 with the true division, it returned 1.5. But just watch and see what is going to return when I do the floor division. So I save and I run. As you can see, it has returned 1. Yeah, which is the integer part of the answer. So you see that the answer is supposed to be, the result is supposed to be 1.5, which is decimal. But if we take the integer part, which is an integer part, which is 1, so that's what it returns. So let's try and put 5 here. Can you guess the answer? Yeah, if you guess 2, you are correct. So let's try and run and see. So it returned 2. Now the next thing that we are going to do is what's the next one in line? That should be what's wrong with this? Yeah, the next one in line should be modulus. Now modulus has to do with remainder. When you are doing a division and you are taking the remainder value. So let's demonstrate that. So let's say I want to still make use of this particular one. So I want to find the modulus of 5 and let's say 5 divide 5 modulus, where is the percentage sign? 5 modulus 2. Now 5 modulus 2, I save. What should be the answer? The answer should be 1, because after dividing after dividing 5 by 2, is going to go how many times? It's actually going to go two types, then the remainder, that should be giving you four remainder one. So the remainder, which is one, is the one that the modulus returns. So when we start finding problems like writing a function that determines even number, odd numbers, and all this stuff, so that's where we'll be applying most of these things. So we are going to be demonstrating most of these things and be showing you. So this is how to check if a number is even or odd. This is the particular operator you use. You use this modulus operator to check that. So let's quickly move over to, I will advise you to practice all this. Okay, but before we move over to variables, let me just show you something in strings. Now, string operations. So let me just show you something. I let's say I printed something like Python. Now I said print Python. Okay, now print Python, I run. Now this will print Python. But can I add another thing? I can also do plus here and also say print Python and print good. Then this will print this thing for me. Now let's say this and see. You can see that this what we call this thing is concatenation. Concatenation. This is string concatenation. You understand? So it's going to print both Python, which is the first string. Now it's going to add it up, like it's going to concatenate it, carrying the right part to the left side. So it's going to concatenate it, and recall that it's not going to add any space. So if you want a space to be in between, so you should manually add the space yourself, which is this print good. So this is called concatenation, is accepted. So you can see that you can use this plus sign in string. Now you can also use multiplication sign. So let's try and see something. So I want to print let's say I want to print something like I want to print Python, or I want to print by name. I want to print Ihechukwu, then but I want to print it 5 times. So I can say multiplied by 5. Okay, let's just do it 2 times, multiplied by 2. So when I save, let me just clear this stuff and now print. You see, the first one is Ihechukwu, then Ihechukwu. So I can print this thing also up to 5 times. So I can also put 5 here and actually save and also run the same thing again, and I'll print the first one Ihechukwu, the second one Ihechukwu, the third one Ihechukwu, the fourth one Ihechukwu. So as you can see, you can actually use the print function to add two strings together. You can use the print function. Let me just show you. Okay, let's say I want to print let's demonstrate that again for emphasis. Let's say I'm actually printing, let's say I want to print Python, but no, I want to print hello, but I want to print it character by character. So I want to type it character by character. So I can say H plus, what's the next thing? E plus, no, yeah, plus, what's the next thing? What's the next thing? Plus L, then plus L, then plus, I've said L plus L again, right? Plus L again. Then the next thing is plus O 0. Oh, so let's quickly run this code and see the outcome. You see, Yola, it gives hello. So you can see that you can also, aside from applying the print function with, you know, other things, aside from applying the operators in normal numerical numbers. You can also apply them in string in Python. Is acceptable. You can use it to concatenate strings. You can use it to do things like that. Okay, so I want you to also explore and also find out so many things that we can do with these operators in the string distance. So now let's talk about variables. Now we can see that Python provides a means of performing operations. Yes, we have seen that. We have seen that Python provides a means of saying 1 plus 1 equal to 2, 2 plus 2 equal to 3, and all that. We have seen that. We have demonstrated that. We have seen that Python, but that's can we store that particular, the answer to that, the result of that equation into a variable? Can we? If you said yes, you are very, very correct. Yeah, we can store that. So that's where variables come in. That's where variables come in. So variables in Python are symbolic names that reference are symbolic names that reference store data. Now, symbolic names, okay, that store data, something like that, reference or store data. That was a mistake, or store data. Then variable declaration in Python is done this way. The variable should be in the left hand side, then your equal sign, then what you're assigning, the right answer. So what is basically saying is that you are assigning 3, the value of 3 to x. So you are taking the value of 3 and you are assigning it to x. So this is somehow different from mathematical assignment, because mathematical assignment says that x is this one now is assignment, not basically equal to in comparison. So don't worry, when we start doing comparison and conditional statements, we'll look more into that. So but x is assigned the value of 3. Now let's try and see that. Let me just demonstrate that and show you something. Let me just, sorry about that, let me just demonstrate that. So let's say I say x equal to 50. Can I print the variable? Of course, yes, I can print x. So I can save, and I also can print. As you can see, it x is equal to 50. So can I also say, let's say y equal to 30? Then I can now say print x. I can now say z, okay, let's say sum equal to x plus y. Let's just do something, x plus y, then x plus y, then product, which is prod, equal to x times y, So let's print all this so we can say now print. So I'm going to use f and there is what we call string formatting. I've not taught you that, so but I'm going to apply it here. Okay, no, let me just leave that. So I will just say, what should I say now? Print sum, then equal to, then I'll put a comma, equal to, sorry, print equal to this. Then what's this thing is sum, then comma again. Then I will say product equal to, then comma, then what is that? Prod. So let's save and run and see what we have. So as you can see, this is this. So but don't worry, let me just do something. Let me escape this. Let me put this in a new line, so I will show how it can be. So as you can see, it says sum equal to 80, the sum of, which is the sum of 50 and 30 is equal to 80, and the product of 50 and 30 is equal to 1500. So as you can see, variables, you can assign variables in Python. So variable assignment in Python is very, very valid. Is very, very valid. So it makes the job very, very easy for us. So you realize that we are not just repeating sum. Will come here and repeat x plus y. Then we are not repeating it. We just assign and repeat. We are not saying sum equal to, we are now saying 5 plus 30, 50 plus 30, then product 50 every time. So we are not saying that. So you realize that it actually helps. It actually helps. It actually helps. So this is very, very good of Python to actually, provide all these things. So now naming rules for variables. Now these are the naming rules that you have to adhere to whenever you are naming variables. So the first one is variable names must start with a letter or an underscore. So variables, you cannot just, come and want to name a variable and the variable is starting with a number. No, no, no. It's not valid in Python. So the variable must start with a letter. So let's just show you that and see, or an underscore. So I can put an underscore here, underscore x. Then I can also put underscore y. Then I can put underscore here. Then underscore here. Then here I can also, do the same thing, underscore. Then here, sorry. Then here I can also do the same thing. Sorry about that. Then remember, just see I'm changing everything, so I can save and run. You see, it still works. It still works because underscore is valid in Python. Now, what if I what if I decide to use a number? Let's say 9 first. Let me just run the first code. Let me just show you what it will write. The first one. You see, it's showing as a syntax error, invalid decimal literal. So it's seeing this thing now as a decimal literal. You understand? So when you are naming variables in Python, one of the rules is that variable names must start with a letter from the normal letters. We have A to Z, small letter, lowercase, or A to Z, uppercase, or an underscore. Now, subsequent characters can be introduced. So, subsequent characters. So I can say X1 is valid, or S underscore. So that digit must not precede it, but digit can succeed the distance. Now, also variables are case sensitive. Lowercase age is not the same thing as this, that the first letter is uppercase, and it's not the same thing as the age that all the letters are cases, because these are different variables. Let's just demonstrate that and prove that that is valid. So I'm going to comment all this stuff now. Let me just comment all this. I'm going to comment this. So let me just show you something. Did I comment that? Oh my god, so sorry about that. What's wrong with this? So I'm going to comment all this. So now let me just show you something. Let's say age equal to let's say 20. Now I'm printing. I want to print age. I save. Now I print. It's correct, right? It's showing me 20. So what if I want to print age? Let's save and print. As you can see, it's saying name error. Name age is not defined. Did you mean age, which is this one? So you realize that What Python is now saying is that you did not define these because these and these are different variables. They are different variables. So when you are naming, please just be consistent with the convention. So I normally I normally name my variables with lowercase as lowercase letters, symbols. I don't use uppercase. Now, where you use except when I'm naming a class, that's where I can use an uppercase as the first letter. So that is another convention. You understand? So so that's that. So let me just show you now. Avoid using Python's reserved keyword as names. Example, if, else, while, for. So all these things are Python keywords. Also print. So I cannot name something as print now. Let me just show you something. Then I will now come and say print. I will name it as this. Is a very wrong practice because these are Python reserved word. Or I will come and say if equal to 20. No, no, no. No, it will throw an error. It will throw an error. Or I will come and say else equal to 20. No, these are reserved words. If I use print now, print would assign quite alright, but it will conflict with it should conflict with you. So in order to avoid syntax error and semantics error, just stick to the well-defined naming, variable naming conventions. Okay, so that's that. So let's try a problem. Now, let's try a simple mathematical problem. A simple mathematical problem. So you are given a right angle triangle where one side adjacent to the right angle is 6 units down units long, and the other side opposite to the right angle is 8 units long. Find the length of the hypotenuse. Hypotenuse. Find the length of the hypotenuse. So from Pythagoras theorem, we know that hypotenuse is equal to the square of the adjacent plus the square of the opposite length. Now we are going to solve that in Python, but before we do that, let me show you something. Now let me show you how to take the exponent of something. So let's say I want to take let's just assign a equal to, so I want to take the a raised to power 2, sorry, 2 raised to power 2. So this is how you do that. You use double multiplication sign, double star. So let me print a and see, what it shows. So you see it's 4. Now let me also try 3 raised to power 2. 3 raised to power 2, that's 3 squared. So this is how we do that. You see it's 9. So you use double multiplication sign, that is double star. So let me also show you. So let me just comment this out and say that's raised to the power of what, 2. Now let me also show you something again. So if I want to find the square root of something, now I want to find the square root of something. Can you guess that? Yes. So let's say I want to find the square root of 9. The square root of 9, I will say times, yes, 0.5, right? So let's print and see. The square root of 9 should be 3. So let's run and see. 3.0. So it's returning a float. So you see that when you use this is the fact that this is because from the mathematical relationship, when you raise something to the power of half, automatically it gives you the square the square root of that particular stuff. You understand? So when you raise something to the power of half, it gives you the square root of that particular stuff that you raise to the power of that. So with this thing in mind, so you are going to solve this problem. So when we make C the subject formula, you will see that C now, which is the hypotenuse, is equal to the square root of what? The square root of adjacent squared plus opposite squared. Adjacent is 6 and opposite is 8. So can you try this out? Can you try it out? I believe you can try it. Okay, let me just give you some time to try it. So you can go ahead and pause this video and try it out yourself. You can try it out yourself and see. You can try it out yourself and see. So just rename this X, just rename this Y. So let's try that. So our A, which is the adjacent, is what? Is it 6? Yeah, it's 6. Then our B, which is the opposite, is what? 8. Now our C, we do not know our C, so our C should be equal to the square root, right? So let me put a parenthesis first. Now the square root of A squared, right? So A to the power of 2, then plus B, right, to the power of 2, then all to the power of half, 0.5. So if you did this, you are very, very correct. So I'm going to print it. So I'm going to say hope I got the spelling, hypotenuse equal to C. So hope we got that right. Let's print and see. You see, that's it. So the 6 to the power of 2 is 36, and 8 to the power of 2 is what? That should be 64. 64 plus 32 is what? 36 is what? That's 100. Square root of 100 is 10, and it returned a float. So that's very, very wonderful. So if you got that on your own, that's very, very good. So let's also try another problem. Now suppose we have a circular garden which has a radius of 3 meters. Now the circular garden has a radius of 3 meters. Now calculate the area of the garden. So we are left to calculate the area of the garden. Now to find the area of the garden, we know the formula in our mathematical classes. We know that area is equal to pi times the square of the radius. Now the radius here is given by 7 meters, and our pi, which is a constant, is 3.142. so let's try and calculate the area. Let's try and calculate the area of that. So R is 7. So our pi is 3.142. So we are not importing anything now. We just stick to that value. So our area should now be equal to 3.142 times what? Times 7. Okay, so let's put it in a bracket. Times 7, then times 2. You understand? So when I print this now, print this. So I'm printing A. So I save, then I print. So as you can see, let me just make this very, very presentable. So I can say area equal to that. So save and let us print. So you can see that this is the first one. Now this is it. So I believe you understand what we did there. So I will advise you to also practice some problems. You can take some mathematical problems, model them into Python, and practice them very well. So you can take some mathematical problems. So when you take those mathematical problems, you model them in Python, you present them in Python and solve them so that you become very, very conversant. You know, practice makes perfect. So you become very, very conversant with Python, with practicing everything about Python and all that. So let's go ahead and move to comments. Now, as you can see, you may want to put in a few words addressed not to Python but to humans in your program. So especially because when you start writing bulky programs, you remember you'll be surprised that after you must have written a code, and you are coming back maybe after 6 months to check the code, you'll be shocked that you don't know what a variable actually does. Or when you are writing a code that many people are going to use, so maybe you're writing a module, or you're writing a function, or you are just writing a code, you are collaborating with your friends to develop a software. So you realize that you need to define what a variable stands for. You need to define that so that your friend can know what, okay, the definition you are giving is actually ignored by Python, so it's just for humans to read and understand your code. So as you can see, we did that here. So this is called a comment. So what it basically does is the interpreter actually ignores it. Whenever it sees it, it ignores it. So you can see that when I come back to this particular code in the near future, I can say, okay, wow, what is happening here? Wow, okay, I raised this to the power of 2. Wow, wow, wow. Then this is square root. So I can say that. So for you to comment, just a hash first, then you write what you want to write. So I can say that reduce, assign the value 7. This is a comment. Interpreter is going to ignore it, then hash. I can now say finding the area. You understand? So if I run this code, nothing will change. Nothing will change. So this is actually where we're going to draw the line closed for this part 1 of this Python. So in part 2, I'm going to show you many things. So let me just show you one. I'm going to show you how to interact with the user. Let's say I want the user to input something, so I can say please enter your number. So I'm going to show you this in our part 2 class. You see that? So I can say 2 3, then I run. So I'm going to show you all these in the second part. So we are going to dive into the interactive aspect of Python, how to interact with the user, and also, how to write conditional statements. So we are going to dwell more in conditional statements, for loop. We are going to dive into conditional statement, if else statements. Then we are also going to talk about loop. We are going to talk more, and we are going to solve a lot of problems. So I will advise you to make sure you solve a lot of problems, and make sure you also go back and study these things again and again, and also subscribe and push your notification bar. Subscribe and let your notification bar be turned on, so that you will know when we post the next video. We are going to be posting tips on programming, how to learn fast. And remember that where all this is heading is to data science. So if you want to be a data scientist, if you want to be an AI engineer, a machine learning engineer, you want to know a lot about machine learning, you want to make predictions, you want to build APIs. So I want you to stick on this channel. Make sure you subscribe. Also share to your friends so that they can also learn. And I'm also going to drop my link. I'll drop my WhatsApp contact on the description so that you can always contact me on WhatsApp. You can always contact me or call me if you encounter any problem or any difficulty, or you need a question, you want to ask a question. So that will be all for now. Make sure you subscribe, hit the notification bar button. Okay, that will be all for now. See you when we meet again. Bye for now.